So the distance formula. In two space, what was it? It's this. You might use D for distance, or sometimes they'll use this. In R2, the distance between point P number 1, which by the way has coordinates x1 and y1, and P number 2, which has coordinates x2, y2, is in two space, and they'll write it this way in your book. The distance from P1 to P2, they'll write P1, P2 between absolute value signs for distance, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Can you switch the order with the points? Could you do x1 minus x2?
Yes.
And y1 minus y2? Yes. And so I like to give this for an example. Anybody in here from Lafayette? That's always a good one. How far is it? How far is in miles? How far is it from Baton Rouge to Lafayette?
It's like 50 or 60 miles.
50 or 60 miles. Okay, let's say 60 miles. The distance from Baton Rouge to Lafayette. Okay, what's the distance from Lafayette to Baton Rouge?
Negative 60 miles.
Ah, distance can't be negative. Did you see though I switched the order of the cities? If I switch the order of the points, it's the same. So if you do, you don't have to worry about which one is x2 and x1. By the way, this is really just the Pythagorean theorem. It is a version of the Pythagorean, it's a Pythagorean theorem solved for the hypotenuse. That's what it is. All right, so that's what it is in two space. In three space, in R3, the distance between P1, which is x1, y1, z1, and P2, which is x2, y2, z2, is, well, they'll write it distance from P1 to P2. It's the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared plus z sub 2 minus z sub 1 squared. The proof of that really uses the Pythagorean theorem applied 2 or 3 times. Yes?
Does this apply to any arc of the edge, so any amount of space?
I think so, yes. I will say yes to that. I'm thinking, now you got me thinking about my 4,000 level math books. And they do have it like that when they're talking about higher dimensions. So here's the distance formula. Let's do an example with the distance formula. I want to find the distance between these 2 points. Find the distance between -3, 0, 4, and 6, 2, -1. So you just plug it into the distance formula. And I didn't say one of them is P1, P2. This time I'll just say D for distance. The distance is the square root. Now, do I want to do -3 minus 6 or 6 minus -3? I think I'm going with the 6 minus -3. 6 minus -3 squared plus, then for the y's, 2 minus 0 squared plus for the z's, -1 minus 4 squared. And I'm going to be careful with my handwriting. Make sure you extend that square root sign as far as it needs to go. I've seen students make mistakes when they get a little sloppy and they don't extend it, and the next step they put it even shorter and then shorter, and before you know it, the problem's, what they've written is totally off. Well, 6 minus -3, that would be 9. So 9 squared plus 2 squared plus -5 squared. If you use your calculator, make sure that you do -5 times -5, because what is that? That's just 25 right there. 9 squared, 81. 2 squared is 4. -5 squared is 25. So now you're going to get 81 plus 4 plus 25 is the square root of, let's see, I think 110. Square root of 110. On the test, I would prefer that you leave the answers in exact form. I know you could plug this in the calculator and get a decimal. Depending on what you're finding this for, might determine whether or not you want the decimal or the exact form.